Then let's look at the questions. So that would be week 13 outline. Okay, you have well, you don't have many questions. You have 12 questions, and some questions are pretty easy. First question, find the request related to Unix. So that's easy one. Give $100 commission to a rundown employee. Does anybody have a question? Anybody have a question on that one?
Yes.
You do? Okay. So let me open that open developer first. Okay, so let's see, that would be 1, 2, 3, 4. Okay. All right, so that question basically has two parts. First of all, you need to find out what is the rundown employee. So in that case, you could just say select rundown employee. So I get employee number or employee name, does not matter. So here I'm going to create a temporary table, and then that temporary result will be ranked by rundown number. So select start from EMP, and then we will do so there's nothing else to do. That's basically order by DBMS rundown data value. Okay. And so from that, so basically you just reshuffle the table, and then from that you get the employee number, just the first one. So where row number is less than 2. So that will give you the employee who rundown employee. So now I put this into subquery. Okay. And then try and update that employee's commission. So update EMP set. I think it was a commission, right? Commission is equal to MVL count 0 plus 100. You understand why we need MVL, right? If a commission is missing, then you cannot just simply add 100 to it. And then where EMP number equals to or in, that would be okay too, either way. So that is the question to that. So let me copy that question here. Dash. Question is, okay, give $100 commission to run an employee. Okay. Any other questions? Let me look at the next question is find the rank of department in terms of total salary. Does anybody have a question on that?
Yeah, would you mind doing that one as well?
Okay, so let's do that. Okay, so what do we do? Let me copy the question here. So in this case, we are finding each department, finding the rank of each department in terms of total salary. So apparently we need to use EMP table, right? So we'll do select DPD number, yeah. And then total salary, which is sum. Okay, cell. And then let's say as total cell. Okay. And then we are going to look at the rank. So say rank of this over that. So rank. Okay. And then we say over rank over, actually we should do this over here, right? Rank over sum of the salary, sum of salary over cell. So we are going to do in descending order, order by sum, the DESC in descending order, okay. As rank from EMP and group by the PD number, right? So that will be the department, each department, the total salary, and also the rank. Okay. Or if you want, you can also order by. So let's just add on one more thing. So order by sum of the salary, total salaries again, and also DSC. Okay. And I don't think salary has missing values. If it does, then just say not, you specify which, say not last or not first. Okay. So that would be question 2. Okay. And number 4, find all managers' names and their employees, each manager supervise. Does anybody have a question on that?
I do.
You do? Okay. So let's do that. Okay. So here we are looking for each manager names and all employees, each manager supervises. So we could, so this one could depend on how you want to represent the result. So let's say the simplest case will be using just get. So we have the reference to this same table, EMP table twice. The once to get employee name, and the second time to get is to get the manager's name, right? So we have the reference to the table twice. I think we did this example before. So let's just do that again. So let's say I would do 2 tuple variables, a.emp number. So those are ename. So that's what be as managers, okay, as a manager. And then b.ename. So that would be employees from emp A and then emp B. Okay, well, just remember that A's manager, A's employee number equals to B's manager number. Okay, so that would be a simple interpretation of that to get employee manager names and also employees each manager supervises. Does that make sense? Or if you think this, you want to just get the manager names and also list of employees supervised by each manager. Just say I want to create a subtable for those employees, and then in that case you're going to use tuple variables again, but then you're going to use a cursor. So select. I will also do say ea.ename as the manager. Okay. And then the second part will be cursor. And now in the cursor, I will do select. So let's say select, I will say b dot emp number, b dot ename, b dot job, or any other columns you want to specify for employees. And that will be employee B. And then say, well, b dot manager is equal to a dot emp number. Okay, reference to this a here. Okay, and now that let's say as employees, as supervises. Okay, and then say from emp A. That's it, right? For each as manager, hold on. I think we need to specify that. So since we have to make sure that those employees are managers, so we probably will need to use where clause. So maybe say a manager is not null. Okay. manager is not a null, so it's to indicate that those people who have supervisors. Okay, so this will be second interpretation of this same question here. Okay, the first one just simply just list each manager's name and also employees' names line by line. Okay, and there's no grouping. The second one we do grouping. So you're going to have managers, and then for each manager, you're going to list all the employees supervised by the manager as subtable. So this is second interpretation. Okay, and then next one, find top 2 largest department in terms of number of employees. Does anybody have a question on that?
I did.
Okay, so let's do that. So here we are going to largest department in terms of total employees. Okay, so largest two employees, largest 2 departments, right? So apparently we need create somehow use like what the total number of employees and use group by, get a count, and then use that result, and then we were trying to reorder that by the total number. So let's do that first. So suppose I trying to get the department and then the total numbers first. Okay, so I will say select the PP number from EMP. Then let's say I'll do group by the PP number. Okay, and then I will order by the total number of employees. That will be count. Okay, so this will give you, so there will be descending order, right? Top 2, right? Descending order. Okay, so this subquery will give you the departments ordered by their total department, total number of employees. I am going to make that as subquery. Okay, subquery, and then we'll go into select the PD number. Okay, and then say from, and from here, from this subquery. Okay, and then we say where row number is less than 3. There we go. Does that make sense? So basically, use a group function to get like a sub records, like get a list of departments ordered by their total counts, and then just from that you find the top 2, which is row number less than 3. Okay. And then create a list of the managers' names. I think this is the same thing, right? It's the same thing as the previous one. So you can use either any one of those 2 interpretations. And then find the rundown department and total number of employees in the department. Anybody has a question on that?
Yeah, I do.
You do, okay. So let's do that. Okay. Find the rundown department and the total number of employees. So first of all, we need to know how do we find the rundown department, right? So we'll do select the PT number from. So I'm going to use subquery to shuffle everything. So I'll say DPT number from EMP, and then say order by let's say total number of employees. So this one we could just do from DPT, does not matter, right? So we just run down from rundown department DPT, and then order by rundown DBMS rundown dot value. So this will give you a reshuffle the department table, and then we'll just get 1. So where row number is less than 2. So this whole thing will give you a rundown department, right? And now we just need to find out that for that particular department, what is total number of employees. So let's put that into subquery. And then let's say, how do we find employees, number of employees? So select count, number of employees from EMP, where the PT number in or equal to is y, okay? Equal to this subquery result. Total number of employees in that department. So the department is rundown. You already specified in the subquery. So if department number equal to that, and just count the total number of employees. There we go. So that should solve that question. And the next question should be easy, I think. Find the first 5 earliest hired employees. So basically, you just need to order by hire date, right? And then row number less than 6. And then find 5 rundown employees from a rundown department. Does anybody have a question on that? Number 9.
I did. Yes.
Okay. Matthew, let me do that question here. Okay. So here, first of all, we need to find the rundown department. Okay. So we already know how to do that. Select the PT number from let's just say, I will shuffle the entire department. The PT number from the PT order by DBMS, and then rundown that value. So that will give you reshuffle the department, or rundown reshuffle the department records, and then we select just one where row number is less than 2. So this whole thing will give you a rundown department, right? Rundown department. Okay, so let's put that inside. And then next, we want to find 5 rundown employees inside this department. 5 rundown employees inside this department. Okay, so what I will do is I will just try to select everything from EMP, well, the PT number in here, in this subquery. So that will give you the total the employees, the total number of employees inside this department, the rundown department. But now we need to reshuffle these employees because we want to find the 5 rundown employees, right? So we have to make sure that the whole thing will be ordered by DBMS and then rundown total value. Okay, so then this give you order by so this whole thing from let me start not doing parentheses next. So we'll just say this will give us rundown department, and from the rundown department we just find all the employees in that department first. Okay, and then we reshuffle those employees. So now I will make this as a subquery, trying to get 5 of this. Trying to get 5 of this here. Let me say from this. Okay, well, select from where that, and order by the DBMS rundown. I think there is something. What is here? Let me check. Order by something is, so we would do select. Well, let me try to put this, get rid of that. See what. Let me say the logic is clear. Okay. So what I'm going to do is, first of all, I find the rundown department. Okay. And then I want to find all the employees inside the department. So that would be selecting staff from EMP, well, DPT number in that. Okay, so that part is fine. And then after that, I will just say order by, so that whole thing will be reshuffled. I don't see anything wrong here, so I'm going to close that. Close that. Okay, so then I'm going to select selecting from this records. Select 5 rundown employees. So I will just say ename emp number ename, okay, from this table. And then finally we say where row number is less than 6. So that will be 5, right? There we go. So this is how we do that. It's actually a very good question. It consists of a couple of nested. So you see the logic, how I do this type of questions. I start with simple ones first, gradually construct more complex ones, step by step, okay? And then, it should be, just like a divide and conquer approach to solve complex problems. Okay. Question 10, I think is easy. Just use a SUMX. And then next question, create a directory that lists each manager's name, hire date, department name, department number, and all the supervisors managers. So actually this is also similar to the ones we talked about. Just create a manager's name, hire date, and then department number, and also all the supervisors managed by that. So you're going to use a cursor this time, right? I think this is clear. And then finally, find the numbers that has not been used by department number in the department table. Does anybody have a question on that?
Yeah,
Let's do that. Okay. So basically, in this case, we have to generate the numbers. So, and then say which numbers has not been used by department table. Okay. So we'll do because of the column here, let's say T, and then we'll just say N here. The name of column is N. Okay, S, call it parentheses, and the parentheses. Okay, so start. I'm going to gradually generate these tables, gradually generate these numbers. Okay, so first one is simple. We just get the minimum number from the department. Select mean the PD number as Sn from DPP. So that's basically just beginning the first easy part. So I will get the first number and Sn to start to build this n, and then I'm going to use second part, which is select n plus 1 Sn, okay, from T, okay, and then we have to make sure that the number n is not bigger than the max. Okay, select n less than, select max of the EPD number from the EPD. Okay. And then we have to make this basically is a recursive part, which is calling this record this table that you are trying to build step by step. Every time you have n, then you're trying to n plus 1, and then just make sure the n is not bigger than the current maximum department numbers. Okay, and then we have to just union all. Okay, connect all of them. And so that basically will give you the temporary table that you're looking for. And then we say select. Finally, we select n on T, where n not in. So I'm going to select all department numbers from the PD table. Something is not correct here. What is select here? Let's see. Syntax error. So what is the syntax error here? Select n, which is name of column, from T, name of this table, and where what is not in. Okay, sorry. Where n not in this table, and the number you are looking for is not in this department table. And there we go. So those are pretty possibly more difficult questions in the list. Okay, Now let me ask whether anybody has questions on this.
Could you explain on that last one?
Yeah.
I'm still just a bit confused about exactly what all the parts of that query are doing, like where it says with t of n as. I'm not really sure why that's there.
So with t is the name of table, n is the name of the column for the table. Okay. And then this, basically this whole thing, starting from here to here, is trying to build this table with just one column here, with a column called n. And this column is going to have like values, okay? And which values will be in this t? The first one is going to be the minimum department number. And then from that department number, you're going back to your use. From that minimum one, then you're going to reference to this table, trying to get the next value. So if the minimum is 10, suppose this t, so first you can minimum department number is 10. So then the t will have just one row, which is value 10 for the column n. Okay, and then you're going to use this next query to call this to call this table to try and retrieve this table's n, and then so n plus 1 and make that to be new value n, and that value will be added to the t, and then step by step. So this will just keep on doing that. Okay, so you can think of seeing that as just like a while loop. Okay, so every time you get n for at first n equals to 10, and then your n equals to 11, n equals to 12. So every time you n plus 1 to make that new value into this column, and just when you stop, and this is stopping condition. So when n is reached to like a maximum department number like a 50, then this query will stop. And after that, this table t n column n will have values starting from the minimum one and all the way to the maximum -1, I believe, right? Maybe like 49, 10, 11, 12, 13, all the way to 49. And then after that, you say, I want to select this column from the table t, and then we should make sure that the t is not, that the number selected is not in this table. It's not department number in this table. Okay?
Makes sense, thank you.
Okay, all right. Any other questions? Okay. Now, if there's no other questions, I'm going to save this, and that will be today. What would be that? 11:23. Okay, so I'll save that. Okay, so then I do not need to use this anymore for the rest of the semester. And we are going to move on to MongoDB. So what I will do is we'll start with a PowerPoint, and that to show basic concepts of Mongo database. Sorry, I announced that the coming Wednesday we did not have class, but that was wrong. According to university calendar, we do have class on Wednesday. So actually the Thanksgiving break starts from 4 o'clock. So our class will finish before that. Okay, so that class is probably the last class, I guess, right? Last class for you. So I had to have just one student saying that she will be on trip, so nobody else has any other problems. So that wrong announcement happily did not cause so much trouble to you guys. So I'm very happy with that. But then 3:15 class will be canceled because that class was after 4 o'clock. So 3:15 class, we just have 1 day class, which is today. Okay. So now let me upload the PowerPoint first. And here is MongoDB right here. So ppt MongoDB. So I'm going to email everyone also. So I just uploaded the two files. One is today's outline, and the second one is a PPT. So I'm going to just run the PPT first to get basic concept. And then after that, we'll get into the installation part. Installation part, I also summarized in this PowerPoint, but I'm going to skip because I think everybody has done that, right? So you already have installations. So let me, then we just directly go to practice MongoDB. Okay, so let's see slideshow. Okay, there we go. So move on. So first thing we want to know is what is NoSQL database. MongoDB is one of a non-SQL database system. Okay, so what is NoSQL? NoSQL basically just no relational. It's really not a good name for NoSQL. It doesn't, it probably just means that you're not going to use SQL, right? But actually, it's non-relational. So in the relational database, we know that we are using tables with primary keys, foreign key links, right? But in NoSQL database, we are not use the tables, the primary key, foreign key links. So you are not going to have concepts of a primary key, foreign keys. Okay, so that is that's a big difference. Okay, so instead, NoSQL database will use different data models. For example, there is a document-based model. So in that case, you, instead of using rows or records, okay, instead of using fields, you are using so-called document. Okay, so each row, each record will be replaced with document. Okay, and the field will be actually replaced by something called key value pairs. So I'm going to show you the example of this model, document-based model, and that model is actually the focus of MongoDB. MongoDB is using that data model. Okay, and then there's also a graph model. This is, you can just imagine that we talk about a hierarchical model or network model. It's kind of like that. It's kind of like that. So you're using graph to show, the data nodes, and then your edges to show relationships of data nodes. Okay, and then the simplest model would be so simply just a key value pair. So basically, there's no really structure, just very simple structure. So you have a key and a value, key and a value. So for example, social security number 1111111. Okay, and then name and with gender, and then major, say business. So you're going to just have a list of those key value pairs. So that is simplest data model that NoSQL database is using. Okay. And then next question to answer is why NoSQL database? Why relational database can it's not enough. It's not good, or it's not sufficient for what we need. Okay, so NoSQL database models claim to have the following advantage. What is the advantage? They claim that it is more scalable and much faster at handling very big data. So we talk about big data here. We talk about scalable. We talk about performance faster than traditional relational database. Why? Well, we understand that today almost everybody has like a cell phone or one or two cell phones, right? And then that is kind of like worldwide phenomenon. Everybody has cell phone, and then they are generating a huge amount of data, right? And also they have a huge amount of demand for they always want data available, right? So that is kind of like first of all, they generate big data, and also they want data to be always available. So that's why this this faster performance and scalable is very important. Okay, and also these apps are pretty much distributed systems, and so is getting to the point that if you have, say, if you want all the data to be stored in the relational database, traditional relational database, that is going to it's going to be slow. It's going to be very not very flexible. I will show you why. Okay, just let you know that there's two reasons. Okay, distributed apps and all the inexpensive storage and processing power everywhere. That is pretty much reason to justify that NoSQL database is a way to go for those kind of systems. Okay, and then so let's say scalable. Scalable is actually is scalable. You can just say to add a new demand, and then the system can always handle the increase in demand. So that's a scalable. Okay, traditional database, relational database is vertically scalable. So that means you have a table. The table has a bunch of fields, columns, right? And then you will have more data to be added, more rows, more records to be added. You can just simply add those at the end of the table, right? So that's a vertically, add those. And but with growing demands of there's expensive like cell phones and distributed systems, we actually looking for scalable horizontally. That means we do not want to have like a fixed number of columns. We want to be able to add more columns, whenever we need. But you understand that with relational database, to add more columns is not easy. Basically, you have to use auto table commands to add more columns before you can add data, right? But that may not be satisfactory to some of the growing data needs. So sometimes I just want to add data, and also at the same time say I have new fields. I just add the new fields. I do not want to wait for the administrator to create the new columns for me to add the new data. Okay, so there's a need to be scalable horizontally. Okay, so this NoSQL database actually give that flexibility. They operate without a schema and freely adding fields to the database without having to define any changes to data structure first. So that is all the advantage with NoSQL database. Okay. Second advantage is NoSQL database are typically optimized for specific data model, like just one of the 3 models I explained to you. They are pretty simple, and then this SQL database kind of optimized for that. Okay, so that actually because of that you can get like a higher performance, okay, than traditional relational database. So those are pretty much like 2 advantages of NoSQL database over the traditional relational database. Okay, so that's also why a NoSQL database. Okay, so in order to, let's talk about performance a little bit more. So let's say in order to achieve a performance, scalability, and availability in NoSQL database generally follow a balanced approach. So what is a balanced approach? Is that availability, you cannot guarantee every is always available. Okay, so suppose you open a cell phone, you open an app, you're trying to get data. If the data is not available just temporarily, that should be okay, right? But just make sure the database should be available most of the time. So that is kind of a balance. Okay. Secondly, you do not want to have, so the consistency is another issue we talk about. So when we create a table, we have to make sure the column, will take a certain kind of values, constrained by, what kind of values that column can take. And also there are certain type of, so if you say the data for example, I will talk about that. So if, for example, for the same person, same student, and if his major appeared in multiple places, and then if you change one, then other one will not be this. You're going to have several measures, different measures for the same student, and that will be called an inconsistency, right? And so in relational database, consistency is a very important criteria to be followed, to be always followed. But here, in SQL, temporary inconsistency is a lot. But eventually, you just want to make sure that data will be consistent. Okay, so eventual consistency can be achieved. So that is so-called balanced approach. So in other words, what we trying to emphasize in the traditional database, always available and also always consistent, that may be temporarily sacrificed in order to achieve the performance for NoSQL database. Okay. All right, now let's talk about a few examples about NoSQL database. So NoSQL database are generally open source software. So they are, therefore they have a lower cost. So not like Oracle or Microsoft SQL Server. You have to pay like a huge amount of money to be able to get license to use those database systems. But NoSQL database is free, so open source. Okay, so here are some of the examples here. Okay, MongoDB, MongoDB, and the Couchbase, and the Redis, because those are the examples. So I think I have more detail about those databases here. So for example, Amazon DynamoDB is using key value pair. So data model is a key value pair store. Okay, and then there's HBase and the big table. I did not even show you the data model. It's just like a column store. And then document stores that basically MongoDB, that's one we will be learning. And the CouchDB is also using database data document model. And then Neo4j is using graphical database model. Okay, so those are examples of NoSQL databases. Okay, so when we talk about NoSQL databases and also those data models, we talk about the distributed systems. And basically with any distributed systems, there's something called a CAP theorem. The CAP theorem. So consistency, availability, and the partition. You see the CAP. Okay. So what does this theorem says that any distributed system can satisfy only two of these three properties. So desirable, you want to have things always consistent, always available, right? And also tolerant to errors. But unfortunately, any distributed system can only achieve two of these properties. You cannot get all three properties satisfied at the same time. Okay, and according to this CAP theorem, this is a classification of different databases here. So for example, for relational database like Oracle is emphasizing availability and the consistency, so can achieve these two properties. Okay, and what about MongoDB that we are going to learn? MongoDB can achieve consistency and also partition tolerance. So by the way, what is partition tolerance? Partition tolerance is just tolerant to errors, implying that system will continue to function even when there is a data loss or system failure. So that's a tolerance. Okay, partition tolerance. Okay, so MongoDB can achieve like a tolerance, partition tolerance, and a consistency here. And the CouchDB, and then CouchDB is also using database, using document model is emphasizing availability and also and the partition tolerance. Okay, so that is just based on the CAP theorem that different NoSQL database may be classified. All right. If you have any questions, you can stop along the way. Otherwise, I will move on. Okay. And the next property, 4 properties also related to distributed systems. So this is called ACID properties. We talk about some of this, like atomicity, consistency. We talk about that, right? And also there are two more properties desirable for distributed systems. Those are isolation and the durability. Let's explain all of this. Okay. Atomicity. So that basically say that so each like a database transaction sometimes consists of a multiple SQL statements, right? And then this atomicity have to just ensure that all the statements must be either all run successfully or none of them succeed at all. So basically, each transaction either succeed or fail. Okay, so you should not have like a transaction halfway finished, halfway successful, halfway fail. That's not good for distributed systems. Okay, so atomicity guaranteed that each transaction is treated as single unit, atom, right? Single unit here, and which either succeeds completely or fails completely. You cannot leave anything in the middle. Okay, so if you leave anything in the middle, then your database is going to have big trouble because you're going to have, for example, you withdraw cash from one account and then trying to credit that account or not credit that amount to another account, but then you withdraw, you already deducted from one account, but not credited to another account, then you're going to leave that, you're going to have big trouble with customers, right? So that atomicity is a way to guarantee that no such transaction can be allowed. Okay, And the consistency, well, it's just explained. So basically, you have to, values has to follow those constraints, and then, the cascade basically means that we do not cover access database, so we do not use the concept of cascade. We did a cascade constraints, right? Cascade constraints. So for example, we're trying to remove or delete a row, whatever, and then if there's a constraint, you use a cascade constraint. That just ensure that those constraints will be also removed. Okay, triggers is some kind of program that will monitor database changes. So when something happens, that we trigger another program to audit, to create like an audit trail, and then to bring the data back to the the consistent state. Okay, or maybe a combination of that. So this is a desirable properties for any systems. Okay, consistency. What is isolation? Isolation just ensure that if you have if you're trying to do concurrent transactions, everybody, for example, trying to book airline tickets, right? So several different agents are trying to book airline tickets, and then they are doing that simultaneously, concurrently, right? So this isolation have to use property to ensure that those executions, even though they are doing concurrently, but the result should be same as they are doing sequentially. Just result is the same as the one after another one. All the transactions will be conducted in a sequence. Okay. So in other words, by doing multiple transactions simultaneously, will not change the data, change the database state to to some kind of wrong, incorrect state. In other words, so the result should be same as if you're doing those transactions one by one in a sequence. So that's called isolation. And the durability is guaranteed that the transaction, if it's committed, it should remain committed even though you have a system failure. For example, you have power failure, whatever. Committed means saved. Okay, so if a transaction is saved, then it should be saved. Does not matter whether it has a power failure or not. Okay. All right, now let's come to MongoDB. So we have about 25 minutes, I think. Okay, so let's talk about the MongoDB. First of all, this is document-based document store model. Okay, and then the record is same as. So those are the terminologies. So instead of using record or row for relational database like Oracle, we are using concept called document or object. Document or object. So each row representing a document. Okay, a record is created by a document. A document is a combination of field and value pairs. And here is an example. So this is one document. So this symbol for document is just this curly brackets. So the curly brackets surround a document. Okay, and inside document it just simply have a key value pair. So this name is key. And then the value inside double quotes as for text, right? Text value. So that is that's the value. And age is a number, and then this number 10. So those just simply is a list of these key value pairs separated by commas here. Okay. And then we have an array, your database in a programming class student learn array or list, right? So if you have a value like a list of values, then you put a square bracket surround those lists. Okay, so that is also different from relational database. Remember in the relational database, list will be using parentheses, right? So parentheses, and then instead of using a single quote, we use double quotes here for values, for text values here. Okay, these text values, and this is actually same as C# or Java. Okay, there's in Java for text values you put inside double quotes in C#. Okay, and then for like a list, you're going to use a square bracket, right? Okay, and then for numbers, you leave a number alone like this. Okay, and what about this key? The key names, there's keys. There's key names. Or this you do not you have a choice. You can either put double quotes around it, double quotes around the age, double quotes around the groups. That's fine. But without them, if there's a one word name, that should be okay. Without, you don't have to use double quotes. Okay, but if you use double quotes for around this name, that's fine too. That's not a problem. Okay, and this document is actually using so-called JSON format, JavaScript object notation format. Okay, and I think 2 weeks ago I told you that the two most sorted job skills in the job market is JavaScript and SQL. Okay, so it's JavaScript. So MongoDB, to use MongoDB, you do have to speak JavaScript. Okay, so I will demonstrate that to you. Okay, so JavaScript, we are not going to have extensive time to talk about JavaScript in this class, but I will show you, the basic nature of JavaScript when we get into MongoDB database. Okay, so JSON stands for JavaScript Object Notation. So this basically is just like a format for JavaScript to save object data and to exchange object data. Okay, and this is the format. Okay, so what do you need to notice? Just make sure that for each document, you are going to use this curly brackets to surround that. Each document is a list of key value pairs, and if you have a multiple list of values, array of values, then use square bracket to surround those lists, and then put a comma separate those. Okay. And JavaScript, notice some basic knowledge about JSON. JSON is an open standard for data storage format, and JSON uses human readable text. You can tell that, right? So from the previous one, you can pretty much you can just say what is the meaning of those values, right? And JSON is a data interchange format for programs for JavaScript. Okay, and at this point in time, I can just reference to another data format, which is also open format for storing data and also exchanging data. That is XML. XML is for API to communicate data to save data. Okay, XML is also human readable text. Okay, so in today's app development world, JSON and XML are pretty much widely used data communication format. Okay, so basically when you get into like a system integration class next semester, and we will have 3 weeks on JavaScript and 4 weeks on JavaScript and also 4 weeks on XML. Okay, those are two very important data formats for communicating for inter-program communications. Okay, and the JSON is a native data format to store and transmit objects by many programming languages such as JavaScript. Okay, JavaScript is that is a programming language that make your website live. So when you open a web page and then you see some kind of dynamic, web page is typically static, but the JavaScript will make it alive. So when you mouse over something, it's trying to do something, right? When you mouse click something, the JavaScript will do something. Okay, you can also put JavaScript as like a programming language for the server also. That is called Node.js. Okay, so basically, this JavaScript is a very, very useful programming language to learn. Okay. All right, so MongoDB also allows, this is another thing that in the relational database, we're using so-called primary key foreign keys, right? So trying to say where, for example, department, has many employees, to know those each employee, then you have to have foreign key like department number here. But instead of using that kind of a foreign key relational primary key foreign key links to join, to connect multiple different records, here in MongoDB, you can actually allow so-called embedded objects. So in other words, you can have objects inside objects. Okay. So for example, I have some kind of person document. Okay. The person name is John, and he has 2 addresses, and each address is also a document. So he has 2 documents inside each. This John's document. Okay, so in that way, you do not need to use, primary key foreign keys. So you can just embed address inside person's object. You see that? Okay, so this is how you do that. So remember that curly brackets is document, right? And then each document consists of multiple key value pairs. Here we have one key value, name, John, and also second one, address, and also the values. The values here in this case is array. So surrounded by square brackets. And in the array, we have 2 values. Okay, one is address document 1, second is address document 2. So they are just representing 2 different address documents in here. So documents inside the documents. So that way we do not have to use reference, use primary key, foreign keys. Is that clear? Okay, so also remember that for text values, put inside double quotes. Okay, for that, this one just have text values. Okay. All right, and MongoDB organized same kind of documents into something called collections. So now we're not talking about tables anymore. We talk about the collections. Does it make sense? So records is same as document, and then table is same as the collection in MongoDB. Okay. However, there's a difference. There's a big difference. Table has multiple columns, right? The columns most times are fixed. Okay. Of course, you can add more columns, but then you have to follow the normalization, right? So that is, that's restriction. And here with MongoDB, collection is schemaless. So there's really no fixed structure. Our documents in the collection can have different fields. For example, the following one, we have one person has a name field and the age field. But the second document for the inside the same collection has social security, name, and also groups. See that? So basically, that you say that the structure of a collection is pretty fluid. Okay, and so maybe next time you have a different user using cell phone to create another document. The document may have totally different fields. Maybe have a social security, have a name, and also maybe something like an interest. Okay, hobbies. Okay, so that's all possible. Okay? And then JSON. We said JSON is a simple data format for JavaScript to communicate and save data, object data, and MongoDB is actually precisely is using so-called binary JSON or BSON. Okay, binary JSON. So what is binary JSON? It's just like the JSON document is in binary encoded format. Okay, and so that may not make much big difference. However, the big difference is JavaScript. Remember, JavaScript does not have data types. Does not have fixed data types. So we'll learn how to create variables in JavaScript, okay? But here, BSON actually have a certain kind of data types allowed in the data model. So for example, like a data time format, that is extension. And this object ID is another type of data. So for example, this object ID, okay? This object ID. So this is actually a special kind of data. In this object ID, it actually consists of 3 parts. Okay, the first part is the object ID is using hexadecimal number. I talked about hexadecimal number in 315 class. So hexadecimal number is using 0, 1, 2, all the way to 9, and then A, B, C, D, F. Those 6 numbers to represent one digit, one bit, one single digit. Okay, so you say that every 2 of those numbers will represent 1 byte. So this object DB actually consists of in total 12 bytes. Okay, but the first 4 bytes representing timestamp for the object that it was created. Okay, and then the second 5 bytes will be just random numbers, and the last 3 bytes will be just like auto number, serial number for the documents. Okay. So we'll learn how to get this timestamp separately. So basically, every time you create a new document, and then it automatically put a timestamp on it. The timestamp is already inside this object ID. Okay, so you can use this function get timestamp to get the timestamp from here. So timestamp is this object ID is one type of data that's beyond JSON. JSON does not use that. Okay, but it is inside BSON. In other words, is kind of a data that can be used for MongoDB data type. Okay, and the second data type is data time. Data time. Okay, data time of course is very common. You go to Oracle, there's data, there's a date field, right? That representing exactly 1 point in time. And you go to like C# or Java, they also have a date, and but this BSON also have that date format. Okay, and how to enter data value? There are two ways to enter data value here. So first one is using a function called isODate, and then you can just put inside here. I think there's double quotes here. There should be double quotes, and then put exactly like I say year number, month number, day value, and then say time, the t, and then exactly time, hour, minute, second, and also there's a millisecond. Okay, and then z, this z stands for like a what is called the standard time. The standard time, which is and what is called what is that called? Using London's time. So basically, is so all this, all point in time actually is using number of milliseconds starting from 1970 January 1st, the early morning, like 0 o'clock, total number of milliseconds. So that is representing exactly one point in time, starting from that. Okay, so this is how to use one way to use data format. They're using enter date into binary MongoDB date. So use isODate. The second way is using so-called constructor. So students in 315, that you probably understand that better, the concept. So you can use a new date. I'm going to show you that also. Say, for example, year number, month number, and day value, and hour, minute. So basically, that's the second way to enter a data value in MongoDB. Okay. In Oracle, you remember that you use a single quote, right? And then the day value dash, and then first three digits, three letters for month name, and then dash, and then four numbers for year number, right? So that was Oracle data, the way to enter data. But in MongoDB, these are two ways to enter data values. Okay. All right, and data types again, just kind of like overview of data types for MongoDB. So you have a text, string, integer, double, and also arrays. That's just in square brackets, surrounding list of values. Okay, and timestamps. Timestamps by default is using 64-bit, but when we talk about the object ID has like a 3-4 bytes for timestamp. It just means that this timestamp actually, even though it have 8 bytes, 8 times 8 is 64, right? 8 bytes, but only 4 bytes are essential. Only first 4 bytes are essential part. Okay, so the timestamp is using 8-byte date. We just talk about that. Object ID, we just talk about that. Binary data, suppose you're installing data into like images or music into MongoDB, then you're using binary data. Okay, null is another data type also here for null values, for missing values. So those are list of MongoDB data types. Okay, and I have like 5 minutes. Let's just try to go through a few more slides before I think hopefully before we reach to the installation part. Okay, MongoDB query language also have support basically inside SQL. We do create, read, update, delete, right? So basically those CRUD operations are supported by MongoDB. Okay, you can also do data aggregation like using group functions, finding statistic functions, max, min, group by, all that. And also you can do type searches. Okay, and then this is just some demonstration of how suppose I have a collection with 2 documents. These 2 documents just for 2 employees, right? 2 employees here. So if you want to find, you're not using SQL here. So instead of say select, you want to select star from employee, okay? You're doing something like that. Say start with DB, and then that's this name of collection, and then dot find. Okay, and then if there's any criteria, you put a find inside the parentheses, you put a criteria. Okay. So db.employee.find will get all the document retrieved from collection, the employee collection. Okay. You can we'll skip that aggregate functions. So we'll probably have to wait until you come back from Thanksgiving talking about this so-called group by. Okay, aggregate so-called aggregation pipeline. That's just group by. Okay. Good. And MongoDB also have some limits. Okay, some ways and to overcome those limits too. So for example, for BSON, the maximum document size is 16 megabyte. So in other words, remember that, curly brackets, inside you have a list of list of key value pairs, right? So the whole thing cannot be more than 16 megabytes. Okay, so there's a size limit. What then? So in that case, how do you handle a large document like a music, MP3, or some kind of video, or some kind of a book chapters, or that? So in that cases, MongoDB using technology called GridFS to divide the file into parts known as chunks, and store them separately, store them as separate columns. So I'm going to explain that just a little bit more detail on that. Okay, so this is GridFS. And then what if you have database server which is lost, and MongoDB has actually using so-called replicates. So use copies and replicates the instance of one database to different database servers to provide redundancy and high availability. Okay, and then we talk about large data, big data. Then you often get so you take so much time to read and write input and output, and the CPU is also limited. For that, MongoDB using a technology called sharding as a method to distribute data across multiple systems. So those are three technologies that MongoDB handle beyond the limits beyond limits that overcome those limits. Okay, so here's, for example, this is a GridFS. How does GridFS work? Okay, so basically GridFS was storing and retrieving large files, images, audio files, video, all that, right? So you can just think of that. You use MongoDB 2 as like a database, like operating system, like a file system to store files. But just one word before I talk about that is that you should not use database to store files, because that is just causing your database kind of like overinflated. Okay. So the better approach is still put files in the file system and then have a reference inside database. Okay, but if in case you want to put files inside your database, that's okay. MongoDB supports that. So how does MongoDB handle that? Is using so-called GridFS. The GridFS, actually you're going to have two collections, two tables. Okay, one table is called just store files, information about the files, and the second table is the information about the chunks. So each file is divided into like a chunk with maximum size 255 kilobyte, right? And for each chunk information you stored inside this chunks here. Okay, and so basically so each file is going to like a file ID, object ID, and that file ID will be inside here as like a foreign key, but it's not called foreign key, it's called a reference. Okay, inside these chunks. Okay, so here, let me give you a concrete example here. Suppose I'm going to upload a file like this into MongoDB. So you're going to use this command. Okay, it's a GridFS and the put. Put means just upload the sum. Okay, and then after you finish that, you will be able to see query the first table, which is fs.files, and find, and you will be able to find the file information. Okay, file information here, and then to find the chunks belong to this file. For this file, so those individual parts of this sum, then you're going to use chunks.find, and then say file ID equals this object ID. This object ID is here. Okay, so then you get a list of chunks for this file. Okay, so that's just so you can do that outside the class, trying to practice, trying to see that how does that work. Okay, I think we are almost there. MongoDB was a relational database like Oracle, so those are terminologies here. Database, same as database. Table, we don't talk about table, we talk about a collection. Record is replaced by document. Columns, we don't talk about columns. Instead, we talk about key value pairs. Okay, each document have its own value, key and the value. Okay, so you can see those are the fields. Okay, and ACID transaction, we'll talk about ACID transaction, atomicity, consistency, isolation, and durability. Those transactions, those properties are the same thing. Secondary index, joins, instead of using joins, okay, explicit join, like a primary key using primary key, foreign keys. Here we talk about embedded documents. Okay, and the group by is aggregation pipeline. All right, so I think I should stop here. So here, this part will be talking about MongoDB installation. I hope everyone has installed MongoDB and is working. As I showed you at the end, you just simply go to command type Mongo. It will show up, say this is working successfully. If you have problems, then you make sure that you fix that before Wednesday, because Wednesday before the class, I'm going to start to work on this MongoDB. Okay, so follow this installation, just make sure you're successful. So I'm going to stop here. Let me see whether anybody has questions in the last minute. So I'll stop recording for now.